Welcome back to exploration of basic mathematics.
Trigonometry. Part 2. Right-angled triangles and its sides ratios. The triangle. A triangle is a closed-shaped figure in a plane with 3 angles, 3 sides, and 3 vertices. Three vertices are A, B, C. Sides are AB, AC and BC.
Angles are angle A, or angle CAB, angle B, or angle ABC, angle C, or angle ACB.
The right-angled triangle. Right-angled triangle has one angle right angle. That is 90 degrees. As sum of all angles in a triangle is 180 degrees. So other two angles, angle AE, angle B, add up to 90 degrees. Angle AE, angle B are complementary angles. If we know one of the angles, angle AE, and angle B, we can draw a definite shape of a right-angled triangle. To draw a specific right-angled triangle, we must know at least one side of the triangle, along with angle A. Please note, of 3 sides, the opposite side to right angle is always the longest side and it is called hypotenuse. Other 2 sides are opposite and adjacent to the angle A. Draw a triangle with 3 given sides as 3, 4, and 5. Please note, it is a right-angled triangle. And also note, 3 square plus 4 square equals 5 square. With this observation, Pythagoras was first to state the Pythagoras theorem. Pythagoras theorem states, in a right-angled triangle, the square on the hypotenuse equals the sum of the squares on the other 2 sides. That is, a square plus b square equals c square. the triangle with three sides. Can we calculate values of angles? The right-angled triangle with one side known, can we calculate other sides? If one angle A is known, the trigonometry has the answer. How? We will learn it now. The right-angled triangle ABC has three sides: A, B, C, and angles A, angle B, and right angle C. The opposite side to right angle C, AB, is called hypotenuse. Other two sides. The side BC is opposite, and the side CA is adjacent to angle A. For angle B, the opposite and the adjacent are interchanged. The side CA is opposite and the side BC is adjacent to the angle B. Draw three right-angled triangles with same sides ratio. Three sides are as 3, 4, 5, 6, 8, 10 and 9, 12, 15. Overlap the triangles at A to confirm if the angles A is same. Note here in all three triangles and the ratio of the side opposite to the hypotenuse. The actual value of the ratio of opposite to hypotenuse depends on the value of the angle A. In trigonometry, this ratio is defined as sine A, or sine of angle A. Sine A equals opposite divided by hypotenuse. Draw an angle A. And from angle arm AB drop a perpendicular BC on another angle arm AC. For angle A, side AC is adjacent, side BC is opposite, and side AB is hypotenuse. On extending the angle arms AB and AC, and drop more perpendiculars from B1, B2, B3 to C1, C2, C3. Please note, the length of the perpendiculars B1, C1, B2, C2, etc. increases as the arm length AEB1, AEB2, etc. increases. Note here the triangle ABC, triangle AB1C1, and triangle AB2C2 are similar triangles, as all three angles in these triangles are same. So the ratio of the sides will be equal to trigonometrical ratios. Trigonometrical ratios are sine, cosine, and tangent. And in short, we use in trigonometry as sine, cos, and tan, or sine AE, cos AE, and tan AE. Sine AE equals opposite divided by hypotenuse. Cos AE equals adjacent divided by hypotenuse. Tan AE equals opposite divided by adjacent. Any side of the right-angled triangle, and can be calculated using following form. Let's explore further sine AE. Draw three right-angled triangle of hypotenuse of same length. As angle increase, as A is smaller than L and is smaller than P, so is sine of angle AE is smaller than sine of angle AE and is smaller than sine of angle AE. The value of sine of angle AE depends on the value of the angle AE. As we know in the right-angled triangle, the hypotenuse is greater than opposite. Note: at angle AE equals 90 degrees the hypotenuse equals the opposite and sine AE equals 1. So the maximum value of the sine AE equals 1. Note: in right-angled triangles below, as angle A gets smaller and smaller, the sine A will also be smaller and smaller. When angle A equals 0 the opposite will be 0 and sine of angle A is 0. Remember, as sine of angle AE is the ratio of the two sides, it does not carry any unit, only number. Let's explore sine AE at a value of angle A equals 30 degrees. Draw a right-angled triangle ABC of angle A equals 30 degrees. Draw an arc at the point B of radius equals to AE, to locate a point D at hypotenuse. So the line segment DB equals BC equals AE. Please note: triangle BCD is an isosceles triangle. As side DB equals CB, and angle DBC equals 60 degrees. Angle BCD equals angle CDB equals 180 to 60 by 2 is equal to 60. Or triangle BCD is equilateral triangle. And sides DC equals BD equals CB equals AE. Now focus on triangle AECD. Angle DAEC equals 30 degrees and angle AECD equals 30 degrees as angle DCB equals 60 degrees. It makes triangle AECD an isosceles triangle and line segment DAE equals CD equals AE. So the hypotenuse AEB equals AED plus DB equals 2AE. Using Pythagoras theorem, AEB square equals AEC square plus BC square, or 2AE square equals B square plus AE square, or B square equals 3AE square, or B equals under root 3 into AE. Note here, sine of 30 degrees equals 1 by 2, and sine of 60 degrees equals under root 3 by 2. Also note, cos 30 degrees equals under root 3 by 2, and cos 60 degrees equals 1 by 2. Sine of 30 degrees equals 1 by 2 equals cos of 60 degrees. Sine of 60 degrees equals under root 3 by 2 equals cos of 30 degrees. Simply, sine AE equals cos B equals cos 90 minus AE. Cos AE equals sine B equals sine 90 minus A. Let's explore now sine of angle 45 degrees. Draw a right angle triangle AEBC of angle AE equals angle B equals 45 degrees and angle C equals 90 degrees and with sides AEBC. Triangle AEBC is an isosceles triangle. Side AEC equals BC equals AE. Using Pythagoras theorem, AE square plus B square equals C square, or AEB square equals AE square plus AE square, or AB equals under root 2A. So sine of 45 degrees equals 1 by under root 2, and cos of 45 degrees equals 1 by under root 2. Trigonometrical ratios of complementary angles. The complementary angles are angles whose sum is 90 degrees. In right angle triangle AEBC, angles AE and B are complementary angles. Cosine, here prefixed co, is for complementary. It means that the ratio of the angle is equal to the co-ratio of the complementary angle. Sine AE equals AE by C equals cos B, and sine 30 degrees equals 1 by 2 equals cos 60 degrees. We define another complementary ratio cotangent, or cot AE equals adjacent by opposite equals B by AE. So tangent of angle AE equals cotangent of angle B. For example, tan of 30 degrees equals 1 by root 3 equals cot of 60 degrees. Now we summarize all 6 possible ratios of the sides of the right-angled triangle. Opposite divided by hypotenuse equals sine AE. Adjacent divided by hypotenuse equals cos A. Opposite divided by adjacent equals tan A. Adjacent divided by opposite equals cot A. Other twos are defined as secant, sec, and cosecant, cosec. Hypotenuse divided by adjacent equals sec A. Hypotenuse divided by opposite equals cosec A. Their ratios are related as sine A equals 1 by cosec A. Cos A equals 1 by sec A. Tan A equals 1 by cot A. Trigonometrical ratios in a triangle. Draw a triangle AEBC with sides A, B, C. Drop a perpendicular from vertex B to the side AEC at D. Let BD equals D. So in the triangle AEBD, sine AE equals D by C, or D equals C sine AE. And in the triangle BDC, sine C equals D by AE, or D equals AE sine C, or D equals AE sine C equals C sine AE, or A by sin AE equals C by sine C. In the same way, we can show using CE as perpendicular, or E equals AE sine B equals B sine AE. A by sin AE equals B by sine B. Or finally, A by sin AE equals B by sine B equals C by sine C. Thanks for watching this video. You may continue to watch our other video also on this channels.